Hello, I'm going to show you how to get a root console on one of these newer Philips Hue bridges, so the 2.0 version. And you need very few tools for this. You need some wire or paper clips or something like that. You'll need a Torx driver to take the bottom off. You'll need wire cutters and a USB to serial console cable and a computer. Alright, so let's begin by taking this and opening it. Step one. And basically grab the bridge out, looks like that, and we don't need this other stuff right now. You'll need the power supply eventually, so we'll just plug that together. There we go. Alright, so now we're ready to go. So the first thing to do, flip it over. There's a bunch of these little pads, and you can just peel them off, and I just slide them out like that. 2, 3, and under this you can get your Torx bit in here. So actually the hardware build quality from the version 1 hub has improved quite a bit because they have nicer screws that go into these little metal bosses you see on the inside. Take this guy apart. There. And the final one. Alright. So it just sort of pops apart like this, and there's the main board. Be careful of there's a switch under here that you can really easily knock off because it's quite high, as you can see, so just be careful you don't break that. On the first one I was playing with, I did that. So what we have inside, just out of interest here, let's move this light over a bit. So there's the main sock. It's a QCA 4531. This is the DDR memory associated with it. You can see all the traces with the matched lengths there. Oops, there we go. So you can see all the wiggles there. Up here is a flash memory. So this is a NAND flash memory. And this holds the major part of the boot. Let me get there we go. So this holds the Linux file system and everything like that. We also have, there's a little SPI flash up here. So this guy actually holds the U-boot. This is the bootloader. So it first loads from here, and then that will load this NAND flash memory. What else we have up here is a Atmel SAM microcontroller, SAM R21 something or other, and this is a combination of 802.15.4 radio and ARM micro with the SPI flashes on the other side for it associated here. And this little guy, interestingly enough, is a USB to serial. It's PL2303, so the serial port for the communication is done through a USB serial microcontroller. This is then connected to the USB bus on the main sock. So sort of an interesting design system there. Alright, so let's get going. So what we'll need to do, we'll zoom out here a bit, is we're going to first set up the serial port. And to do that, move all this stuff out of the way that we don't need. There's a header along the bottom here, and this is your this header has the serial port connection on it. So there's ground is, let's just get a paper clip here. So ground is the first one there. And then the fourth pin over, 1, 2, 3, 4, should connect to the RX pin of your USB serial. So on my cable, this is the green, or the TX pin, sorry, that's the RX. So this is green one's the output, will connect to pin 4, and the white one is the input to the computer, and that'll connect to pin 5. So one of the easiest things to do, I mean, you can solder a header on this, but we only actually need it temporarily. So I'll put it up, and again, watch this doesn't get broken on you if you push down really hard. What you can do instead is, if I have something like a wire or a paper clip, I may be able to jam it in, jam it into those holes. So I'll just do that. So you need it to, if you sort of release it, you'll see it's very flimsy in there. So an easy trick to do is to give this wire a little bit of a kink of some sort. And then when you put it in this hole, hopefully, might need a little more of a kink. When you put it in the hole, it will stay a little bit easier. That might be good enough. So sometimes it works, sometimes it doesn't. So ground. What was the next one? Next one over is green. So we'll do that again. So fourth over. The fifth one is white. So probably can't see too well here, but if you don't want to solder, that's an easy way to do it. Alright, so we'll see if that makes good enough connection. So the next thing we need to do is actually power up our computer. So I'm going to use a little Microsoft Surface here just to demonstrate that you can do it with any type of computer. Alright, there we go. Move this over. And so I'm using Putty, and you actually don't want to use a generic terminal program. Once we get the actual terminal up, you have a lot of coloring and stuff like that, so you actually do want a something like Putty here. So all we're going to do is switch it to serial. In this case it's COM3, and 115.200 is the baud rate. Alright, so nothing too exciting yet. Now we can power up this board and see if we get all of the debug statements printing out for us. So if we get the debug stuff, we know our serial port's working. You may have, if you, oops, again, be very careful of this little thing here. If you switch the TX and RX, if things aren't working, you can just try swapping them, seeing if that works. So, alright. So right away we see we are getting a bunch of stuff. Oops. So this will just be all your boot messages. So it's booting Linux here easily enough. Blah, blah, blah. So what we actually need to do is we want to stop the boot process partway through. And what will happen is that if I scroll up here, early on in the boot there's this message here. This is the U-boot loader, and basically what we're going to do is we're going to cause, after this message comes up, sort of a little before this actually, we're going to cause this NAND flash that it's reading from to be corrupt. So this is sort of, this was used already in like the Wink attack. It's a quite well known type of attack. It's nothing too special. And how we're going to do that is we're actually going to just short out. I mentioned that there's a NAND flash chip here. So let me just, this NAND chip here in the middle. What we want to do is we want to connect this point right here to ground. So we'll use a wire or again a paper clip or anything like that, and we can short out from another header here. So down at the bottom here you'll see one of these pins. This bottom one is actually a ground pin, and so all I'm going to do is I'm going to sort of bend a paper clip such that it fits like that in the ground hole, and at the right time, oops, come up. At the right time, I'm just going to reach it over here, zoom out so you can see where I'm touching, and touch this little point there. So when I touch it like that, should cause the system to fail. So let's see if we can get everything in one frame here. And again, all I'm going to do is turn it on. And you need a few messages to come up, and then you short this out. Yeah, there we go. And if I look at the screen, what I actually see is this message here, device 0 not available. And it's dumped out to the U-boot prompt. So at this prompt, you can do whatever you want. So you can get a help menu. What's of interest to us is if we type this print environment, it prints some environmental variables, and this includes a bunch of the boot strings. So there's a few things we can change on them. So the first one we're going to do is there's this one called boot delay, and you can see by default it's set to, sorry I keep going too close here, it's set to 0. So if you set this to something that's non-zero, what will happen is that it'll let you use the serial port. You won't have to do this NAND trick anymore. So let's just set that to start with. So if I go set environment to variable, what did I say that was called? Boot delay. Boot delay, and it's set to 3. So it's set to 0. We're setting it to 3. So you can see there's a space. Boot delay 3. And if you want, you can always check that you've done stuff right. So you can see it's now set to 3. And finally we'll just say save environment, and this writes it all to non-volatile memory. So if I power cycle this hue, what you'll notice is that there's now there'll be this counter that comes up and says press any key to enter the boot menu. So now I can just hit enter. So I no longer have to do that NAND flash hack anymore. I have 3 seconds to hit enter. The next thing we're going to do is, I have some of the commands I need written down here, is we can actually change the root password through this, because what happens is there's a default, or no, the root password is loaded from that little spy chip. So when I go print environment security, it's called, there's this string here, and this is actually whatever the root password is, so it's encrypted. We don't actually care. We're not going to crack it or anything like that. Instead, we're just going to take the easy way out, and we're just going to change that to something else. So one of the key things here, if you do this, and I'll have a link to all the actual commands, so you can see I just set in environment security. There we go. And whatever this string is. So this string I used make password in Linux to make the encrypted string for Tor. So that's what my password will be, just root backwards. It's very important you have these escapes, the single quotes around it. Otherwise, if you don't, it won't get set correctly. And I'll just copy that in there so you can see. And there you go. And you should check that it got set correctly, like so. And you may, I don't know if it actually matters, but you probably want to keep the old one just in case you ever need to set it back to factory default. So it does seem to be different from what I can see, and that may just be that the salt here at the beginning is different, and it's not actually unique per device. So I'm just going to copy it into the bottom of my file here. So that was the default one. So this default is different from the other system I looked at. Alright, so that got set right, it looked like. So just make sure I copied that right. 3 and 4, yep. So then I'll go save environment. The other thing you can do, so in this case, we're adjusting the root password. You can actually change the boot command to run. So this is sort of what I originally did to figure out the system, is we can change the init command. So when the system's booting up, it just runs a shell and gives us root without any password needed. So to do this, I would have changed one of the boot commands. So you can see this init equals /bin/sh, and it's the standard underscore boot args. The other one didn't seem to have any effect. Anyway, so you can now power cycle, or at the console you can just type reset. So again, we have the auto boot, and it'll just boot up the standard Linux stuff. So we still need these, so we still have all the stuff attached to the console for now. And eventually it just sort of stops, so it doesn't by default come up with a menu here. Oops. Adjust my camera a bit. And all you do is you hit enter, and it'll now ask you for a login. It may print some other stuff, so just ignore that. And I put root as the username, and password Tor. Yeah, so there we go. So they have some other, actually this is different. In the other one this message said Hue 2.0, so I think this must be an unupdated one. That's funny. Anyway, so there, yeah, we're root, so you can go CD around, look at different files, stuff like that. Probably the first thing you want to do though, because this serial port might be annoying, let's get Telnet running. It actually has Dropbear, which is an SSH server, but for some reason it didn't let me log in on that. I checked the config, it seemed okay. So all we're going to do is we're going to go to etc here and use vi to edit rc.local. So this is like the easiest way to do it. There's probably a better way. So insert, and I'm just going to insert up at the top. Hello, you can see my face there in the reflection. 2 commands. And sorry for videotaping the screen, it's the easiest way to get the board and the screen in at one. I don't feel like editing right now. Yeah, so this rc.local, I'm going to do 2 things. I'm going to open port 23, the telnet port, and then I'm going to start the telnet daemon. So we'll just copy that. And we just chuck that right into this file. So I hit insert key first. If you haven't used VI, you might get a little frustrated. I hit the insert key first to enter insert mode. I then pasted that in, and then to escape VI, escape, and then we'll go write file and quit. Alright, and hopefully we now have a telnet daemon will run when it restarts. So let's just figure out what the IP will be while we have this terminal connected. You could go in through your router and stuff too if you want, but it's always annoying. Okay. So I have config. So yeah, what's our IP address here? So 37 up here at the top. Alright. So let's reboot. We'll just power cycle it. Yeah, so again it'll boot Linux, and with any luck what we'll be able to do is actually get in through the network. So I'm going to use PuTTY again because Windows 10 doesn't have Telnet installed by default. Switch to Telnet mode there. 192.168.1.1. 168.0.37 and open. And I think the system, it takes a minute to boot. Yeah, probably it's not finished booting yet. Okay, we have fixed focus now. So the issue was this, the rc.local file, it didn't seem to save the changes. And what it may have been, actually, I realized, is that I power cycled the system right away without halting it, so I probably didn't write it to, may not have written it to actual memory. So again, right quit, and I'll actually use the shutdown. Or halt, what does this system have? Yeah, so there's a halt command, so if you type halt, it will then give you a proper halt, and it should write everything to disk. So, okay. Now if we power cycle it. Hopefully that worked. Yeah, so anyway, but you can see it's quite easy to hack these little things to get you a root console over serial, and hopefully this works and I'll be able to show you a root console over the telnet. So same deal, switch telnet again, and 2.168.0.37. Let's see if it's booted. Okay, init complete, and you can see some messages about the Ethernet, so it probably is up. Ah, perfect. Okay, so what you see now is another login prompt. Root. Same deal. Root Tor. So there we go. So now we're connected over Ethernet, and we do not have to worry about that pesky serial port. So I can close it off. I don't actually know what happens yet when you update. We'll have to see how it saves it. I'll take my serial port stuff all the way. So I just did a little test. Actually, I did an upgrade through the Hue app, and here you can see this is the normal message when you sign on. They seem to have changed it to in the latest version. But you can see I didn't have to change anything. So the one thing I did do is I did make one change in the etc. directory. There's this sys upgrade. If I open that file, sysupgrade.conf. I don't actually know if you need to do this or not. I did it, and I didn't check. I don't have a way to check without it now because I've already upgraded my system. You can see I added the file /etc/rc local, so edit that file, save and quit. And again, before you power off the system, I recommend typing halt and hitting enter. When you hit that, it'll kill the connection, but that makes sure things get written to disk. So yeah, it seems like this is actually could be a reliable way to keep the telnet command open, and the app still connected to the device and let it upgrade and stuff, even though I've changed the root password. So the app must not be using the must not just be SSHing in or something like that. I assume they have their own server that's accessing, listening to commands and whatnot. But yeah, so yeah, hopefully you enjoy this little tutorial on how you can play around with these guys. So it's a pretty cool little platform, and I hope you have a lot of fun with it. Thanks for watching.